let's take that same spring that we found in the last video. Okay, so we know that it has spring constant K. We know that if I attach a mass to it, it's going to be stretched by some distance x0. Okay, but now let's say I take two of those springs. So K and another spring K. And now let's say I attach a mass to that. So I know that it's also going to be stretched by some distance, and we'll call this distance d. Okay? So the question is, what is d? Is it going to be x0? Is it going to be bigger than x0? Is it going to be smaller than x0? So I want you to pause the video for a minute, and when you do, I want you to think about this and figure out what d is going to be. Okay, so now let's take a look at this and see if you were right. So remember that we said that that if we balance out the forces, we see that the gravitational force is going to be equal to the spring force. So K is mg over x, or in this case mg over x0. So this is our spring force K. And so if we look at the forces of gravity on here, we see that we have gravity pushing us down, and we have a spring force pushing up on the block, right? But then on the spring, we're also going to have the same spring force pulling down, and that's going to be opposed by another spring force pulling up. And then, there's going to be another spring force pulling down from the top. Right? So in other words, both of these springs are going to be stretched, and they're both going to be stretched by a distance x0. So the first spring is going to have been stretched by x0, and then the second one is also going to have been stretched by x0. So d is equal to 2x0. So, so as you might have guessed, if I attach a mass, it's going to be stretched twice as far. And I'm going to take a quick second to address the case. So, I've also seen, it's also very common to think it's only going to be stretched by the same distance x0, because you say, well, we measured the spring has spring coefficient k, so that means that this should also be x0. But I want you to think about this for a second. So let's say we have a rubber band, okay? And so you know what the spring coefficient is, and you tie something to it, and so you see that it's stretched, by, so let's say that before you've stretched it, that the total size of the rubber band is maybe like 5 centimeters, and then you attach something to it, and it gets stretched by like 15 centimeters. So you attach something and it you stretch it much further. So by the argument that it's going to be stretched by the same distance no matter how long the rubber band is, that means that if I take some tiny rubber band, that's maybe 3 millimeters, by that argument, if they should stretch the same amount no matter how many rubber bands I have, that same rubber band now should get stretched by 10 centimeters also. Okay, so we can see that we know that it should stretch by a different amount depending on how many springs we have tied together. But this also has another interesting effect, and this is, so if you thought that it would be x0, you're actually onto something else. If we write our spring coefficient k, we see that it's mg over d, which is mg over 2x0. So in other words, we'll call this k effective. And we see that if we have two springs, one on top of the other, so two springs in series, that The effective spring constant is the spring constant of one spring divided by 2. And then you can imagine if I have one spring and I attach a second spring and a third spring, and I do this a bunch of times until I have n springs. Okay, so the spring coefficient for n springs is going to be k over n, where k is the spring coefficient for just a single spring. So we see that when I add springs together, I'm actually I'm actually decreasing the spring coefficient. And so you can imagine something like this, like if you have like a bungee cord, like a rubber band or a bungee cord or something that stretches. So the longer you make it, the longer it's going to stretch, and what that means is you're effectively lowering the spring constant. And so what we really care about is we don't care about this fundamental spring constant k. What we really care about is what the effective spring constant is.